Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 10th video, but I'm only focusing on chemical equilibrium. This is the second bonus video actually guys. So please guys do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your final examination. So please do share this video to your peers so that they may have the same edge as you. And please guys do help us grow the channel by just subscribing. Okay, consider the balanced equation below for a hypothetical reaction that takes place in a 2 cubic decimeter container at 300 kelvins. Okay, we do have our balanced equation over there. First question, they want us to define the term chemical equilibrium. Chemical equilibrium, guys, is just a state of a chemical reaction whereby the rate of the forward reaction is equal to the rate of the reverse reaction. And please, guys, do not forget that we can only establish chemical equilibrium in a closed container. Okay, the amount of each substances present in the equilibrium mixture at 300 kelvins is shown below. Okay, we have 0.8 moles for both our for both our reactants rather, and then 3.2 moles for the products. And then now we are told that the temperature of the container is now increased to 350 kelvins. When the new equilibrium is established, it is found that 1.2 moles of compound P is present in the container. Initially, at the previous temperature, guys, the amount of P was 0.8. So this simply means that, this simply means that an increase in temperature favored the reverse reaction because the amount of P ended up increasing. So if P will increase, Q will also increase, but D will decrease. Are you together? So an increase in temperature basically favored the reverse reaction that increased the reactants and decreased the products. Are you together? But remember that, guys, an increase in temperature will forever favor an endothermic reaction. If my reverse reaction is endothermic, that simply means the forward reaction must be exothermic. So over here, guys, the heat of the reaction is negative. Why? Because the forward reaction is exothermic. So our change in enthalpy has to be negative. We must use Le Chatelier's principle to explain the answer above. Okay, an increase in we've seen that, guys, an increase in temperature have increased our products, and for us to know an increase in temperature rather has increased our reactant. Are you together? And for us to increase the reactants, that means we must favor the reverse reaction. If the reverse reaction is favored with an increase in temperature, that simply means the reverse reaction is endothermic, and hence the forward reaction is exothermic. That's why the change in enthalpy for the forward reaction has to be negative, because the forward reaction is exothermic. Okay, they want us to use Le Chatelier's principle to explain. Okay, we just did that. Now they want us to find the equilibrium constant at 350 kelvins. So how can we do that? Okay, I simply had 2P. That's 2P Q2 and then 2PQ as our products, ne? Yes. Okay, and then we'll obviously have initial moles, the change in moles, the moles at equilibrium, and then we'll simply have our equilibrium concentration over there. That's initial moles, the change in moles, moles at equilibrium, equilibrium concentration. Previously, guys, whenever the temperature was just 300 kelvins, at equilibrium we had 0.8 moles of P, 0.8 moles of compound Q, and then 3.2 moles of our products. Né? But then the temperature was increased. If guys we increase temperature in an exothermic reaction, the value of the equilibrium constant must decrease. Please do note that. Né? So the Kc value will increase compared to the previous one, and that simply means the yield should decrease by just favoring the reverse reaction. So over here we'll just subtract on the products, but we will add on the reactants. I was told that at equilibrium I had 1.2 moles of P. That means I have gained 0.4. Are you together, guys? So now let's find out the number of moles that were gained for compound Q. I need 2 moles of P to react with 2 moles of compound Q. But over here I just have 0.4 moles of P. I want to know how many moles of compound Q will I need. Just cross multiply. 1 multiplied by 0.4, that's 0.4. 2 times x, that's x. Then x is basically 0.2. That's just 0.2. And then I also have 0.4 over there, because the ratio is just 2:2. So the number of moles there will just be equal to the number of moles there. Okay. So at equilibrium, I will simply have 0.8 plus 0.2, that's 1 mole. 3.2 minus 0.4, that's 2.8. Since I was told that the volume is just 3 moles per cube, it's just how many moles? Or 2 cubic decimeters. So therefore my concentration, I simply have 1.2 divided by 2. 1.2 divided by 2 is just 0.6 moles per cubic decimeter, 0.5 moles per cubic decimeter, 1.4 moles per cubic decimeter. And hence my Kc value, Kc, the concentration of products, PQ squared raised to their stoichiometric coefficients divided by the concentration of reactants. For my reactants, I had P squared as well as Q. And then I just have 1.4 squared all over 0.6 squared and 0.5 over there. So that will just give me my equilibrium constant. Squared divided by 0.6 squared times 0.5. I'll end up having 10.89. Yeah. So the equilibrium constant, guys, is just 10.888889. Just round off to 2 decimal places. That's 10.89. Yeah? The equilibrium constant Kc is just equal to 10.89. Okay, now let's answer the following questions. How will the equilibrium constant calculated in 6.3.2 be affected when the volume of the container decreased at a constant temperature? There is no change, guys. Né? The equilibrium constant will just remain the same. The only factor that can affect equilibrium constant is temperature alone. Are you together? So if ever, guys, if ever we tamper with pressure, nothing changes. Rather, the equilibrium constant does not change, rather. Okay, and then now you're told that more amount of Q2 gas is added in the reaction in the reaction mixture at constant temperature. How will each of the following be affected? Choose increase, decrease, or remain the same. The yield. Over here, guys, I am increasing the quantity on Q2. I am increasing the quantity of Q2. Le Chatelier's principle, guys, will favor the reaction that will try to decrease Q2. Né? But for me to decrease the amount of Q2, that means I just need to favor the forward reaction. I must use up Q2 for it to decrease. Are you together? And if I favor the forward reaction, that means I'm using my reactants and I'm forming my products. So what was the question saying? How will an increase in Q2 affect the yield? The yield will increase, guys. Ne? The product will simply increase. Okay, and then now we are being asked about the number of moles of P. The number of moles of P. Ne? By increasing this guy, I'm going to use both Q and P. So the number of moles of P will definitely decrease. The number of moles of P will definitely decrease. That's how, guys, we're supposed to tackle this question over there. So please, guys, do stay tuned and wait for more videos. Thank you.